We're going to learn something really simple today, and that is converting from scientific notation to standard form. And the main thing you need to remember with this is that if you have a positive exponent, then it's going to be associated with a big number. And if you have a negative exponent, that's going to be associated with a small number. Now, what I mean by that is a big number would be a number that is larger than a simple little decimal. Like it's going to be bigger than 1. When I'm talking about a small number, we're talking about a number that has a bunch of zeros after the decimal, like 0.000025. Okay, that's a very small number. Now, your big numbers can have negatives in front, and the small numbers can have negatives in front. We're not really paying attention to the sign of the number. We're only going to pay attention to whether it has a bunch of zeros after the decimal or a bunch of zeros before the decimal, whether it's big or small. So we're going to get into a couple examples here. And if we have a positive exponent, we said that is going to be associated with a big number. So if you look at this is in scientific notation, and it says 5.6 times 10 to the fifth. So when they're asking us to convert this from scientific notation to standard notation, what they want us to do is expand this number so that it looks like a normal number that we're used to seeing. And when you do that, this 5 is a positive number, so we know that this number has to be big. And when the number has to be big, what we're going to do is we're going to move this decimal to the right this many times, whatever that exponent is. And if you think about that, if we move that exponent to the right, and I'm just going to write that down. So you see, I've written the number 5.6, and that 5.6 is what we need to work with. And this exponent right here tells us that we're going to move this decimal 5 places to make this number bigger than a little decimal 5.6. So I'm going to take this decimal and I'm going to move it to the right 5 times. So I'm just going to count as I move it. 1, 2, 3, 4, 5. I've moved my decimal 5 places, and then in each one of these blanks, I'm going to write in a 0. Now, with a standard notation number, we do need to put in commas. So that would be the same thing as 560,000. For the next one, we've got a 2.8 times 10 to the negative 8. We associate a negative exponent with a really, really small number. So this time, instead of making 2.8 bigger, I'm going to make it smaller, this time by moving the decimal 8 places to the left to make this have a bunch of zeros in front of the number. So I'm going to rewrite that number, and then I'm going to take my pencil and move that decimal 8 places to the left to make it a very, very small number. And you can watch as I do that. It'll be, and I'm going to count as I go. 1, 2, 3, 4, 5, 6, 7, 8. So my decimal is now here. And in each of these boxes or each of these loops, I'm going to put a 0. So my new number is 0.00000028. So for every one of these zeros I added in here, I have to put it here, and now this is a very, very, very small number, a teeny tiny number. And you could put a 0 in front right here if you wanted to, but you don't have to. Here's another example. I'm going to take the 8.63, rewrite it, and then this 7 tells me this is a big number, so I'm going to move the decimal to the right 7 places. 1, 2, 3, 4, 5, 6, 7. And then I'm going to put zeros in each of those loops. Once I've put zeros in each of the loops, I will put commas. This is 86,300,000. So this is what I would put in for my answer in Delta Math. This one, because of the negative 3, is considered a small number. So we want to make this decimal even smaller. I'm going to rewrite it, and then I'm going to move the decimal 3 places to the left to make it even smaller. There's my new decimal. In the loops, I will put zeros. So when I go to put this in Delta Math, I'm going to put it in as 0.004208. And that would be my answer. So here's an example of a problem that might be in Delta Math. What I would do is I would take that 2.9, I would write it on a piece of paper. So if you think about this problem, does the -6 tell us to move right or left? Does that mean a big number or a small number? Well, when I see a negative, I think small. So I need this number even smaller than it is now. I'm going to move it left. 1, 2, 3, 4, 5, 6. There's where my decimal is. I will fill it in with zeros. So I filled it in with zeros. So my answer that I would type in the box would be a point, 5 zeros, and a 2.9. So in this blank, I would type a 0.00000029. So I'm going to go into Delta Math and we're going to do a couple examples together and then show you how to actually enter your answers in there real quick. So here I am in Delta Math. I've got this 8.7 times 10 to the -6. I'm going to write that down on my piece of paper, 8.7. That -6 tells me to move the decimal 6 places to the left. So you do this on your own paper and see if you can get the same thing I get. When I do that, what I get is a point, 5 zeros, and an 8.7. When I submit it, I hit yes, and we got it right. Here's one with a positive exponent. So I'm going to rewrite the 3.5 on my notebook paper. I know that 3 tells me it's going to be a bigger number, a big number, so I'm going to move the decimal to the right to make it bigger. I'm going to move it 3 places to the right. When I do that and I put my zeros in my loops, I have 3,500. When I submit my answer, I got it right. So that's pretty much it for converting from scientific notation to standard notation. We'll go in the opposite direction in tomorrow's lesson. So I have a section for you to do on this in Delta Math. Go ahead and get that practice done, and then tomorrow we'll do the next section going backward.